So today I'll be teaching you the first derivative test. Pretty much the first derivative test, all it does is going to tell you where your maximums are and your minimums are. There are three rules you have to remember. If f of x changes from negative to positive at c, then f has a minimum at c, f of c. This kind of makes sense because if it goes from negative, which means it's decreasing, to positive, which means increasing, there's a minimum right here. Now, if f prime of x changes from positive to negative at c, then f has the maximum at c f of c. It doesn't make sense because it goes from positive to negative, so you have a maximum. If f of x doesn't change at c, then at c, f of c is neither max or min, because it's either going to keep going like this, or it's just going to be going like this. There's no change. By now you should be able to take the derivative of a function like this. If you take the derivative, you should get 4x cubed minus 12x squared. As you can see, if you use your algebra skills, you should be able to factor this and take out 4x squared, and that leaves you with x minus 3. To find your critical points, you have to set both of these factors equal to 0. So you have 4x squared equals 0 and x minus 3 equals 0. So if you do this, you divide it by 4, you get x squared equals 0. You take the square root, then x would be 0. For this one, you add 3 to both sides, and you get that x is going to equal 3. Boom. Okay, so now that we have our critical points, we're trying to find out exactly what the derivative is doing as it approaches those points. Since we have no interval telling us the limit, we have to assume that the function is coming in from negative infinity to 0. Pretty much what you do now is you pick a value that's in between negative infinity and 0, and you test it out in the derivative. So we'll take negative 1. Now we have the interval 0 to 3 because of our two critical points. And so we'll just do 2, and from 3 to, oh, not 3 to 0, 3 to infinity, we'll choose 4. So now what you do is you test your first value, so negative 1. So we plug into a derivative, 4. Okay, so this is going to become 1. 1 times 4 equals 4. This is going to become negative 4. So negative 4, so it's 4 times negative 4. That equals negative 16. Since the value is less than 0, we know that the function right here is going to be decreasing. Okay, so now that we tested our first value, now we got to test the second one. So we plug in 2 to the derivative. So that will give you, see, that would be 4 times 4 would be 16 minus negative 1. So this is going to equal negative 16. Because the function is less than 0 right here, we know that the function keeps decreasing. Okay, now we test our last value. We put 4. So we put 4 into a derivative. And this will give us 4 more. So we get 16 times 4, which is 64, times 1. This is positive 64, so the function is increasing, greater than 0. And look, because the function is decreasing and keeps decreasing here, there's no change, so 0 is not a maximum or a minimum. But look, right here it starts increasing, so you know that 3 is going to be a minimum because the function goes from negative to positive, and that's the first derivative test. Okay, so now it's time to do a second example. This problem is a little different because we have a trig value and we have an interval that we have to be careful. So we take, it's pretty much the same thing. You take the derivative, which is negative sine x minus 1. Okay, and you do the same thing. You set this equal to 0. You add 1 to both sides. So look, this is a little bit more complicated because in order to make the sine equals positive 1, you have to remember that the sine value, that you already have a negative right here. So you're looking at the values where what the sign is going to be. Actually, it's going to be negative 1. So because when you combine two negatives, you get a positive. So taking that into consideration, the two values between that interval will be 3 pi over 2 and 7 pi over 2. Okay. So now we have to plug in pi over 2 to the derivative. We have f prime over 2 sine negative sign. If you know your trig values, you should know that the sine value of pi over 2 is 1. Remember that we had the negative 1, you would know that the answer would be negative 1. And so the value of f prime pi over 2 would be less than 0. So the function is decreasing. Okay, now it's time to test out a second value. So we plug in 5 pi over 2 as the derivative. We will get negative sign. The sine value of 5 pi over 2 is also 1. So we get... Remember that we have this negative value right here, so it's going to be negative. So the function is also decreasing here because it is less than 0. Okay, now we're looking for our last value. So it's 5 pi over 3. So we plug into the derivative, we have that. And now we would get that the answer is negative. The sine value of 5 pi over 3 is negative square root of 3 over 2. But look, we have another negative right here, so that would cancel it, and that would make it positive. Because the answer is positive, we know that the function is going to be increasing. So we know that 7 pi over 2 would be minimum, because it's going from decreasing to increasing. As 3 pi over 2 is neither maximum or min because it just keeps decreasing. And that's the first derivative.